And to start with, there are a number of students in office hours that have questions about internal versus external iterators. So I want to show an example to start with. And so in document 11, let me share my screen. Now I need to get all my windows back. Okay. So, simple Java program. I create an array list here. Put some elements in it. Right. So here is an external iterator. I asked the numbers array list object to give me an iterator, and then I can call has next on it. Right. This has been with Java from the very beginning. Now, an internal iterator in Java is the for each. And I pass in a lambda, which is then evaluated in all the elements of the collection. All right. So the external one is called external in part because outside the collection is who controls the iteration, right? We're controlling it right here with this while loop. Whereas the internal iterator, the outside world is just passing in the lambda, and the for each method internally is somehow navigating through the collection. So far, so good. Now, when you Google for each on the web, you get a lot of these simplistic examples like this, which hide an important detail. All right, so here again, instead of printing out, I'm just going to compute a sum. Here's my external iterator, right? The same format has next, but now it's adding all the values to the sum. All right. But now when I try the same thing with an internal iterator, I get this compile error. And one of the issues is, remember, the lambda has to keep track of its global environment. And so in Java, there's some restrictions. Any value I use in the lambda from the outside has to be final, or what they call effectively final. And of course, if I make some final, I can't change it, right? I can sign it once and then I'm done. So to compute the sum like this with the internal iterator, I create a new object, resolve and count things, and then I make it final. Right? But final just means that what new sum points to, we can't change what it points to. We can always have to point to that one thing, but since it's an object, the internal state of the object can change. And then, here's a small little class called count, which allows us to get around that restriction on what types of parameters we can add to a lambda. Any questions on internal versus external iterators? Okay.
Gone over. Sorry. I feel like we haven't really gone over how to implement iterators. And I guess I'm a little confused because on the homework it says not to change the the structure of the or not to like convert it to anything else. But I think almost all of the implementations that I've looked up have basically just changed it to an array or an array list beforehand. And so is it, as long as we so if we're to use the heap nodes, can we change the heap while we're iterating as long as we change it back?
Well, let's say I have an external iterator, right?
Yes.
And so I get the iterator and I start going through some of the nodes, right?
Uh-huh.
And you've changed the structure of the heap. Okay. Now I still have my iterator over here, right? But now from over here, I ask the heap for some, show me something, right? When I have an external iterator, right?
Uh-huh.
I can stop that while loop anytime I want, right?
Yes.
I can stop it and then go do a bunch of other stuff. Now, let's say I stop it halfway through and I don't want any more elements. I'm looking for, does this heap contain 3? Right? The answer is yes. I've gone on, but now your external iterator has modified the structure of the heap, right?
Uh-huh.
And now I want to add a new element to the heap. What happens?
It does not
work
very nicely.
Right. So the answer to that question is, can I change the structure of the heap? No. You don't want to change the structure of the heap.
Can we copy the heap?
So now we can ask those 2 related questions. Can I copy the heap, or do I convert it to another thing, which then get an iterator on that thing, right?
Yes. But you said that the second option is to not do the second option, right?
Right, but there are 2 reasons why I said not to do it. One is so you understand how to implement an iterator, as opposed to using an iterator, which you all know how to do. The second one is, what happens if your heap has 100,000 elements in it? Do you want to make a copy of all those 100,000 elements to iterate over?
Not really.
Not really, right. Now, I'll repeat what I said several times before, right? Um, I think implementing the external iterator is a bit more straightforward, or straightforward conceptually, but actually doing it's a lot more work than implementing the internal iterator. Internal iterator, since you're not used to it, it sounds like I don't know what to do. What? How do I do this? But it's actually, once you understand how to do it, it'll be very simple to do. Now, let's go back to the external iterator, right? So I have this tree structure, right? Now let's put some values in just so we can put a 1 here and a 5 there and a 3 there and a 10 there and no, I don't 12 there. I don't know if that, I'm not worried about how to get here, right? If I want to traverse this node, right, the hard thing about the external iterator is you give me a value and you have to wait until I say, give me the next thing, right? So if my iterator is pointing to here, right, where do I go next? To the next element.
12, assuming this is in order.
Where would I go?
12?
And not 10?
10.
Well, assuming this is in order, there's no way to be at 5 unless you've already been to 10. And you said to do it in order, right?
Yes, but now, so I have to start, my traversal has to start at the root, right?
I figured in the when you first in the constructor you would want to point to the first element.
What's the first element?
Would be 10.
And how do you find that?
By going left as many times as you possibly can.
Meaning you start at the root, right?
Well, yes.
So we start at the root, right? And now what we need to do is we're going to start at the root and it's not, and have to traverse down until I get to the 10. And then I have to wait there, right?
Uh-huh.
And now how do I get the next element?
You can't. You I'm not entirely sure.
Can you have a reference?
Unless there's a way to keep track of.
Can you have a reference to parents in the 10 node?
We need a way of going back up the tree, right? And so what do we do, right? We're going to have to go back up to, so I go back to the 5, and then what do I do?
Right.
And then from the 5, where do I go?
12,
12, and then where do I go?
5, 5, and then 1.
So I'm gonna go through 5 3 different times, right? And I need to know each time I'm going different directions. The first time I'm going down, right, to 10. Second time I'm going down to 12. And the third time I'm going up to 1, right? And now, so we need to keep track of where we go back to. And like I said, we're going to go through 5 3 different times. And so there are a couple ways we can do that. One is we can keep track of, we're going to add parent pointers. That solves part of the problem. But I still need to know when I hit the 5, is it time to print the 5, return the 5, or is it time to go somewhere else? All right. And so one algorithm, you keep parent pointers. You can then try, marking the 5 somehow internally to know how many times you've seen it. But that fails because I can always create 2 different iterators on the same heap structure and iterate through them at different times, right? And so if you start marking internally as the first time, the second time, the third time I've seen it, that's not going to work.
Can't you check when you're on one of 5's child nodes? Check before you enter 5, check which children it has, compare it to yourself, and then you know which direction you're coming from, right?
Compared to ourselves.
So if you're on 10 and you're going up to 5,
Right.
before you go up to 5, you take 5 and you check its left child, and if it's equal to what you currently are, which is 10, then you know that you're going up to 5 from 10. So now you know where to go next, I think.
Yeah, you could probably make that work. The other way to do this, which is suggested in the chat, is let's clean some of this up. Because we do keep a stack, right? And so I push 1 on the stack because that's where I start. I then go down and get a 5, put that in a stack, right? And then go to the 10, right? And now when I want to go back, I pop the 10 off, right? So I can get rid of the 10. And I go back to the 5, and that's the next element I go to. And I can store, in this structure, I can store how many times I've seen it.
I figured a stack would be basically the same thing as not necessarily the same thing, but would still be converting it to a different structure if you're adding things into the stack.
Yes, but what I'm worried about is you converting it to an array list and then using the iterator on the array list. So if you're using a stack to keep track of where you've been, that works. That's okay.
Okay.
Now what's not okay is putting all the nodes in a stack and then getting the iterator from the stack object and then using that iterator to go through the elements. Is that clear?
Yes.
Could you please repeat that line? I didn't get it.
What does not What I don't want you to do is take all the elements of the heap and put them all at once into a stack. And since the stack object in Java has a built-in iterator, then use that iterator to go through all the elements of the stack.
Okay.
Now, basically, I want you to implement the iterator, not use an existing iterator. Someone asked about putting a linked list. The difference between putting in a stack and putting a linked list is that how deep can the heap become? Anyone remember from the algorithms course? If I have a binary tree with n nodes in it, how many levels can you have? As long as it's balanced like this. Yes, log n, right? If I put them on a linked list, then it's n, right? So the difference here is, if I put a linked list, I'm copying the whole thing. And so if I have 100,000 elements, I'm going to double the amount of memory I need. Whereas if I put it in a stack, it'll be much less. Okay, is that clear? Now, the reason the internal iterator will be easy to implement. Talk about the internal iterator. Well, the reason internal iterator is easier to implement once you understand how to do it is internal iterator does not have to stop and remember where you are. All right, because you give it the lambda, right? And it evaluates that lambda on all the elements without stopping. So yeah, you can use recursion, right? Recursion works. Any other questions about the assignment?
I just have a clarification question. I'm pretty sure that the iterator, it should return, like, it shouldn't return the node, it should return the value, right?
Correct. Again, if you're a Java person, go to the Java collection hierarchy and look at what they,
Okay.
You have no idea. I mean, the part of the goal of iterator is to allow you to go through all the elements of the collection without having to know anything about the internal structure of that collection. And if you pass back a node, you're telling the outside world that, details about the implementation. And we do not, when you build a class, right, the goal is to hide implementation from the outside world, right? And it becomes a black box and we can just use it. And so we don't want to expose the physical implementation details to the outside world, or the logical details about how it's built inside. Okay, any other questions?
Professor, did you say we can use stack but not the built-in iterators, but we can use stack and implement the iterators, right?
Yes, you can use a stack that can contain up to log n of the elements in your heap. Well, perhaps there'll be more questions on Thursday. So what I want to talk about today is a visitor pattern. And hopefully you've read the textbook, had one pass through it. This is the one pattern that usually confuses students. So sort of get ready to be confused a bit. Hopefully you'll, before we start, a little saying, because it gets sort of tiring to talk about one pattern after another. Several sayings related to the same idea. A controller, right, mean the manager, right? The system's working well, then the manager doesn't seem to be doing too much. The controller fallacy is if the controller or the manager isn't busy, then they're not doing a good job. And if the controller is very busy, they must be a good controller. And that's both are fallacies. And the shorter version, busy managers mean bad management. How do all these make sense? Well, there's always problems, right? Whether you're going to school, but everyone's got problems. Companies got problems. Working at building software as a team, there's always issues resolved. Some are very small issues and some are big issues. And a lot of times, if you see a problem coming up and you take care of it early, right? It doesn't take much work to resolve it. But if you let it fester for a long time, it gets to be a bigger and bigger problem. And once it becomes too big, then it takes a lot of work to take care of that problem. Right? And so what Weinberg is saying here is, look, if the manager is on top of things, right, then they foresee the problem or they're going to get big and solve them when they're small, right? The classic example is, one day the team wakes up or manager wakes up and realizes, oh, we're 6 months behind schedule. And now it's a big problem because you're 6 months behind schedule and you're supposed to ship in 3 months. It's not going to work. And so now we go in this big panic mode. But you didn't get behind 6 months overnight, right? If you're 6 months behind schedule, you've been slowly slipping for some time, right? And if you wait until it's really almost too late to deal with it, it becomes a big problem. You can have to change the ship dates, or you have to have the, you know, hire more people. You can do all kinds of crazy things to try and get back on schedule. Whereas if you notice that 3 or 4 months ago that you're slipping, it'll be much easier to deal with that problem. Anyway, just something to insert between patterns. So, visitor pattern. The visitor pattern is another one where we're breaking up the basic idea of object-oriented programming, where I say the operations and data should go in the same spot, the same class. And so the goal, the intent, they say, is we want to be able to represent operation outside the class, and so we can form it on the entire structure, right? And so it says the visitor pattern allows you to define new operations without changing the class of the elements in which it operates. Which, give an example, a tree example where I've got, you know, inner nodes and leaf nodes. And now I want some way of displaying or printing out the tree. And so, you know, I want to do it on HTML, so I put it on a web page. So when I build this tree up, I can display the tree. I may want to do you take that tree and embed it as a diagram in a PDF. You know, if you're a tech person, you may do it in LaTeX, or you may want to generate an RTF so you could insert it into Word. And now these, you know, creating a figure in a PDF is going to be complicated. Creating it in a tech document or LaTeX document is completely different, but it's also complicated. You know, do we really want to put, you know, display this tree in PDF or display this in LaTeX inside a binary search tree implementation? Probably not, because that's not part of the abstraction, for one. Secondly, it's going to be very complicated, right? So for example, now assume we have some sort of document, we got HTML document, a PDF document, and a text document. You know, then we can, you know, haul out our if statements and pass in the tree into this print statement and in the document, and then we go through all the nodes in the tree, and you know, if it's an inner node, we're gonna do one thing, but if it's inner node and it's HTML, we're gonna do something different than if it's an inner node in PDF, right? So we get this huge case statement of what type of node is it, and what type of document is it, and then we insert what we're gonna do. So far, so good. And of course, you know, these print statements are going to take a lot of work, and iterating through the tree this way probably won't work. You need to go through, you know, in some order so you know where it goes. top no, root goes here, child's here, children here, etc. Well, we can create, printer class for each different type of document. Right. So then our tree printer, we've got a print tree, print leaf node, print internal node, which breaks up our case statements, right? But they're still there, just nested. Still with me? Maybe, maybe not. Now, it would be nice to do the following, right? Here's my tree printer. I go give the tree document output, and then I've got a print node for inner node, HTML document, inner node, PDF, and then each of my print statements, I can just worry about, oh, I'm printing an inner node on HTML. Forget about everything else, right? So I can fully separate all the cases out, and then using the, overloading, we automatically select the right method when I call print node. Sound good? Will this work? Why not? Parameters meaning what?
Didn't we talk about, was it last class or the class before, that Java can't overload methods like this because it's their the method that you choose is selected at compile time, and these things can change.
Right. The reason it won't work is because Java selects overloading methods at compile time. And so it's going to look at, compiler is going to look at the type of current and the type of output to try and then match, right? And since current is type node and output is type document, right? The compiler is not going to be able to find a best match, right?
This was a single dispatch, right?
Right, we only have single dispatch, and to make this work, we need double dispatch. So now, we can compile there because the compiler cannot figure out which method to call, which one is going to be the best match. Like we said last time, we figure out which overload method to call at compile time, not runtime. So we can create subclasses of our printers. Right. And now in my parent class, I can put my my for loop, right, and then, you know, call leaf node, internal node. And then each of our subclasses now can implement leaf node, printer node for that particular type. And, you know, that's going to work because, you know, I'm looking for which type it is and then calling that method, right? So far, so good. In this case, you know, we can get away with doing overloading in our subclasses if we want. Well, no, we can't. So to make things better, right, we're going to send messages, and those messages are determined at runtime, right? So I'm going to add some methods to my nodes. Print. And then inner node, right? My print method is going to call print inner node and pass in the current object. And the same thing with my leaf node, again, print leaf node, pass in the current object. Here's where double dispatch is going to come in. So now my tree printer class, right? I can iterate through the nodes, right, for all the nodes, and call print on the node, right? If that current node is an inner node, then we're going to go to the inner node dynamically, and the inner node print method is going to say call, you know, print inner node on the document, right? If current is a leaf node, it's going to go to the leaf node and call the print method there and pass in the document, and the then leaf node is going to call print inner node on the document and pass in itself. And this is a visitor pattern. There's several pieces. One is in the structure, and when we visit, we need to have basically two methods, you know, right? In this case, a print method, and it needs to call a specific method on the printer that we're going to pass in. And we've gotten rid of all the if statements. If we create a new type of document, we just create a subclass so that, right, all the work to print on one document is in one place as opposed to different places. And we broke things into smaller pieces. Yeah, I'm going to skip over this. Using so one final step is to make the structure generic. So in the visitor pattern, right, on the elements of the structure we want to visit, we add a method called accept, and we pass in a visitor, right? And then in the accept method, right, what it does is it calls a method on the visitor that helps specify what type of thing we're visiting, right? So it's visit binary leaf tree, visit, tree node. And in the visitor, right, we have an abstract interface. Since we only have two different types of nodes in our structure, there's visit binary tree node, visit tree leaf. And now when we create a concrete subclass, we implement those methods and put the code to do those types of printing in each of the methods. Now a short pause, let this sink in. I'm waiting for some objections to bubble up or questions. Everyone's secretly watching the debate to see what happens.
So in the last slide, basically binary tree node and binary tree leaf implement except in almost exactly. Okay. No, never mind. I see how it goes.
Almost identically, right?
Yes.
But the key point is we're calling a method on the visitor, specifying in some way what type of thing they're visiting.
Okay.
Yeah, it's okay. So the basic idea is, right, is we put operations into a separate visitor. So we have a HTML print visitor, a PDF print visitor. Each visitor basically does one thing, prints the PDF, prints HTML. And in our structure, right, we have this sort of generic accept methods that accept any visitor. Right, so now what happens, right, is that now I have the structure and a visitor, so I pass in a visitor to one of the nodes, right? And I say, node, accept me, accept this, right? And since we're sending a message to an element of the tree, we are going to get at runtime determine what type of node it really is, right? And call the method in that proper class. And that accept method, right, then sends a visit method to the visitor. And since we're sending a message to the visitor object, right, we're going to select the visit method in the class of the object we're dealing with at runtime. So I'm making 2 method calls to get the equivalent of double dispatch, right? Each time I call a method, I'm getting a single dispatch. So if I do it twice, I get 2 single dispatches, which allow us to create a double dispatch. And it's this bouncing back and forth. The visitor will say, accept me to a node. The node then turns around and tells the visitor, visit me, right? So I'm making 2 method calls to get equivalent to double dispatch. Any questions, issues? No. So again, and repeating the same things over again, right? When I call accept on a node, right, and pass in a visitor, what does that do? Oh, it's a binary leaf node. So now inside that, I call on the visitor, right, visit this type of node. So I've now made 2 method calls. The first one is going to specify, we're going to get which type of node it is. And the second one is going to then tell the concrete visitor what type of node we're visiting. One issue with the pattern is if we've got the structure, who's going to do the traversal? It can either be in the visitor or in elements of the structure, or we could have an iterator that does it for us. It depends upon what we need. Usually it's easier for the elements of the structure to do the traversal, but not always. But if we want to have different visitors want to traverse different ways, for example, if we had a heap structure and we wanted a visitor to traverse it in order, another one visit pre-order, then we can't have the elements and structure to implement the traversal. We need to have the visitor implement the traversal. because the traversal becomes different.
Sorry for that last one.
Yeah.
You said if it's usually easier for the elements, but if we're having multiple visitors traversing, it's easier for the visitor to do it. When would we use an iterator? I feel like an iterator would also be helpful, or would be used in that
Yeah.
second case.
Iterator, again, is we're not going to get a different traversal, right? Iterator is always going to iterate the same way. Right. On your heap class, right, your external iterator is always going to traverse one way, right? It's not going to randomly select, oh, this time I'm going to do an inner order, next time I'm going to do a pre-order, right? It's always going to do the same order on the tree.
Okay, I actually had an idea in which you could have established different iterators based on which like traversal pattern you wanted, but I guess that's not very common.
Yeah. You know, with grass and tree structures, right, you can imagine you wanting different traversal algorithms. So there you might want different iterators. But most libraries just give you one. Any other questions? Yeah, the text talks about when you want to use this. It's not the most commonly used pattern from the text. You know, so I think the last one, the easiest one to understand, if you have the structure, you have a tree structure and you want to be able to do different things to the tree structure, it's easier to implement the tree structure, the basic tree structure, and then have visitor pattern, add more of the operations on it. And I did think about adding the visitor pattern to assignment 2, but decided not to. Yeah, also, yeah, visitors make it easier to add new operations. If you just create a new visitor and then you can pass, you know, call accept. And the visitors mean then if you got a print visitor versus a, you know, find all odd element visitor, then they keep those disjoint operations separate, right? The print visitor doesn't worry about odd elements, and the odd element visitor doesn't have to worry about printing things out. But once you change the structure, you add a new different type of thing to structure. So you've got a big graph and you get different type of nodes in the graph. Now you want to add a new node. That becomes hard because that means all your existing visitors need to have another visit this type of node element. It also allows you to accumulate state, so you can go, as you visit through, the visitor can accumulate things. So a simple example is you've got a tree structure and you want to find all the odd elements. While the visitor goes through, every time you come across a node that contains an odd element, you can then store that, and when we're done, the visitor will have all the odd elements inside of it. And like I said at the beginning, right, the visitor pattern does break the basic rule of keeping operations and data together, because we're going to have this basic structure with the data in it, and we're going to create a new visitor, right, for each different type of operation we want to add to the structure. So first I beat you over the head saying keep operations and data together, and now I'm showing you all these ways in which we break that. But in each case, you have to notice that there's the justification, right? If we're going to continually add new operations, then our class will get very cluttered, and that's a problem too, right? Or it may be that we're going to create a library and provide to someone, so we give them the ability to traverse using visitor patterns through the structure, and they can then add operations which we don't foresee. Again, each language has various features. The visitor pattern requires that the structure we're going to visit has these accept methods built in, right? And if you don't have those accept methods, then we can't use a visitor pattern. Many years ago, there was this trend which didn't take out, it got started but didn't catch on, called aspect-oriented programming, which allow you to basically add methods to existing classes. And that sort of fell by the wayside. But now what we're getting are languages like Kotlin, Dart, Swift. They all allow you to add methods to existing classes. Right, so it becomes possible, in Ruby, Swift, Kotlin, Dart, to, if I have a class I can actually add a method to it without modifying the existing class at all, add extensions. So one example I know of the visitor pattern is this system called Margaret. And it basically deals with web pages. For example, you have a page to create an account, and so you want some basic information from people, right? You need their name and their address and email address and all kinds of other information. And there are different types of operations we want to do. One is there are times we want to display the information. So when someone logs on, they want to see their profile. We're going to display all the information for them. When they first sign up, we need to create a form to grab all the data from them. We also need to be able to validate the data, make sure they entered it, make sure the email address is a valid email address, etc. And when they enter it, we need to store the data in a database somehow, right? And so Margaret did the system. It used visitors. You created the model, right? Here is a person object, the user, name, last name, first name, email address, phone number, address, all the information you want. And then you would have one visitor would go and it would just display the information. You give a visitor, you give it a person object, and it would traverse and be the structure of that object, and then create a web page to display the information. A different visitor would basically create a form which users could then enter from the exact same class. Another visitor would use to validate the data, and a separate visitor would use to go through that class and generate the SQL needed to store that object into a database. And so you could, for each domain model, you'd provide some information, the data type, field name, answer constraints. And from that, we would build up, the visitor would use, so it would have various things like, okay, description, here it is, your birthday, it gives a, structure of it, and would use that in the visitor to generate different types of things. A page to display the information, a page to enter the information, a visitor to generate SQL to store that in database. So once you create this domain model, which was a collection of descriptions, the visitor would visit all the descriptions and generate, well, in one case, HTML, one case a form, one would validate the data, and it would save in database. And so when you create a web page, you didn't worry about, you just created a domain model and the visitor would do the work for you. So here's a simple example where we, the form would generate to, based on what the first name, what data type first name is, last name, home address, etc. So that's one example, one instance, right, that I actually used a visitor pattern on, right? It was built into the framework and I used the framework. Many of the other patterns are easier to come up with examples where it's been used. Any questions? everyone has been stuck in the same place for months and it's hard to get excited about anything. So that's a visitor pattern. You should go back now and read the visitor pattern again in the textbook and see if it starts to make more sense. And with no more questions, we're basically out of time. So we'll see people on Thursday.
Thank you.
Thank you.
Thank you.
Thank you.